Hello and welcome to a new video. This is for pre-algebra using the Math UC curriculum. We're in lesson 11 talking about the associative and commutative properties. If you'd like a free notes page to download and print off and use to follow along with these notes, then you can click the link in the description and go to my website and get that. Here we go. Okay, so there are some things that we kind of take for granted sometimes in math as being true, and that's kind of what we're talking, a couple of those are what we're talking about today. There are two properties that we've been using for a while that we want to kind of explicitly state. So explicitly here would mean outright. We want to outright say what those properties are, and the two properties have to do with the order in which we do certain operations. So let's think about this question. 2 plus 3 equals 3 plus 2. Is that a true statement or is that a false statement? And if it is true, then what does that mean? So 2 plus 3 is 5, 3 plus 2 is 5. Those are the same thing, so this is a true statement. And what that means is that it doesn't matter what order our numbers are in if we're adding, that we can get the same thing forward and backwards. So as mathematicians, what we would do is we would try to think, is this true just for these numbers or is it true for all numbers? Because if it's just true for these numbers, that's not necessarily super helpful. But if it's true for all numbers, then we can use that probably to our advantage. One way to figure out if it's true for all numbers is to instead think, is there something that doesn't work for this? Is there a case or a set of numbers that I can put here where it won't work? And after thinking about it for a little while, hopefully you come to the conclusion that no, it works for any numbers you're adding together. As opposed to if we subtract. If I do 2 minus 3 versus 3 minus 2, those are not the same thing, right? 2 minus 3 gives us negative 1, but 3 minus 2 gives us positive 1. So negative 1 and positive 1 are not the same thing. Sometimes we'll mark through our equal sign like this to show that we're saying, hey, these are not equal, but this is not true. So we have basically a property that we can use that works for addition that says I can do it in either order. That property does not work for subtraction. We have two other operations, right? Multiplication and division. Which of those do you think this works for and which doesn't it work for? So let's think about multiplication. 2 times 3 versus 3 times 2. Are those the same thing? Well, yeah, that's 6 equals 6. But what about 2 divided by 3 versus 3 divided by 2? Now, it's easier to actually think about this as them being fractions. 2 divided by 3 is 2/3. 3 divided by 2 is 3/2. Yeah, they have the same numbers, but is 2/3 and 3/2 the same thing? No, those don't equal. So we have this property that's true for addition and multiplication that's not true for subtraction and division. And we call this property the commutative property. So let me spell that out. Commutative. One of the ways that can help you with remembering this is the idea of a commute. So you've probably heard your parents or other grown-ups talk about their commute to work, which is just talking about the drive they make to go to work and come back. So typically your commute is the same going to work as it is coming back. Like you could take different routes if you really wanted to, and they could take different amounts of time depending on like when you leave. But we're supposed to be relating the idea of the word commute with this property to help us remember it. So it's the idea that it's the same forwards and backwards. You go to work, you come back. You go to school, you come back. It's the same forwards as it is backwards. So that's the commutative property. That's our first property we're talking about today. Our second property has to do with if we have more than two things. So let's say that we have 2 plus 3 plus 4. You maybe haven't actually realized this before, but we typically don't add all three of these together at the same time. We have to actually choose 2 of them to add together and then add the third one. So to make it clear which ones we're adding together first, we could use parentheses. Do I want to do 2 plus 3 first in this situation? Or do I want to do 3 plus 4 first in this situation? Or does it matter? If we choose to do 2 plus 3 and then add 4 to it, does that give us the same result or a different result as if we do 3 plus 4 together and then add 2? Well, let's see. This would be 5 plus 4, which is 9. This would be 7 plus 2, which is also 9. So those are the same. And this property is awesome because it lets us choose. If we just have all addition, it lets us choose the order we want to do addition in. And that's helpful because sometimes there are numbers that make sense to go together first that can make our addition overall easier to do in our head. So I'm a big fan of this property. You can probably imagine or even try out and see that the same issue we had with subtraction on the commutative property happens here for the associative property. And we'll actually try that again a little bit later. So what about multiplication and division? Does multiplication work? So we could kind of do the same thing. Remember that you can use dots or x's for multiplication here. Would it work for us to do 2 times and then 3 times 4 in parentheses? Would that give us the same thing as doing 2 times 3 first and then timesing by 4? So here we'd have 12 times 2, which gives us 24. Here we'd have 6 times 4, which also gives us 24. So yeah, it works for multiplication. This is called the associative property. I'm not really sure who came up with these names, but I'm gonna say, for remembering the relationship to the word associative and this property, is that we're choosing what we want to have associated together. Like we get to choose which numbers to associate first, and then which ones to bring in later. So let's look at these more formally written. So here we go. The commutative property of addition, the commutative property of multiplication, the commutative property of addition, sorry, I said the same thing again, the associative property of addition, and the associative property of multiplication. Typically what we'll do in math, and you'll see this more and more from here on out, is when we want to write like a general rule, we'll use letters instead of numbers, because we just use an example of like 2 plus 3 and 3 plus 2. But if it's true for any number ever, then the way we can represent that is by using variables. So in each of these cases, A, B, and C could be whatever they wanted to be, and this should still work. You could literally pick any numbers for them, and it should work out to be true. So we're going to use these properties in our lesson today, and I picked out some problems that are kind of similar to what you'll see in the workbook, so that hopefully this will go pretty easy and pretty well for you. So example 1 says, simplify each side of the equation and tell if the statement is true or false. So this is kind of like what we already did. We've got on A here, 4 plus 7 equals 7 plus 4. So simplifying each side basically means find the answer to each side. So this is 11 and this is 11. Since 11 equals 11, our overall answer here is that this is true. Okay, down here, let's look at B. Now, we're subtracting. 9 minus 2 is 7. 2 minus 9 is negative 7. That helps us see that, what we thought was true really is true. That it works for addition, but it doesn't work for subtraction. The order doesn't matter for addition, but the order does matter for subtraction. On C and D, this is an associative property that we're using. 1 plus 5 is 6, plus 10 is 16. Here, 5 plus 10 is 15, plus 1 gives you 16. 16 equals 16, so that is true. D, 18 minus 3 is 15, and then we would minus 6 and get 9. But here we're saying 3 minus 6 first, which gives us negative 3. We're supposed to be minusing negative 3, which turns us into a plus. 18 plus 3 is 21. Those are not equal, so that is false. So again, we're seeing, hey, the commutative and associative property, true for addition, not true for subtraction. So let's take a look at a few more. Now, this is multiplication. So on E, 5 times 6 is 30. But you know what? 6 times 5 is also 30. So 30 equals 30. That is a true statement. Let's look at F down here for division. 16 divided by 2, well, that's something we can do. 2 divided by 16, though, doesn't divide evenly, although we can simplify it and get 1 over 8, and those are not the same thing. Yes, they both have 8s in them, but 8 and 1/8 are not the same answer at all. So that one's false. Look over here at the associative property. So on G, 2 times 3 is 6. So 7 times 6, which is 42. Here we've got 7 times 2, which is 14. Then we need to times it by 3. That might require you coming out to the side and doing 14 times 3 like this. 4 times 3 is 12. 3 times 1 is 3, plus 1 is 4. So that does give us 42. This is actually, it kind of highlights, to me at least, how it can make a difference which ones you choose to do first. Because for me, it's easier to do 2 times 3 and get 6, and then 6 times 7 and get 42. That's just all multiplication table stuff. But you doing it the other way, where you do 7 times 2 first, and then times by 3, we have to go out to the side to do work. So that's just one of the reasons that it can be helpful to be able to pick and choose what you want to do first here. H, division. You should already hopefully have kind of an inkling of what you think is going to happen here, right? We're going to do 6 divided by 2 and get 3, then 12 divided by 3 and get 4. Here we do 12 divided by 6 and get 2. We do 2 divided by 2 and get 1. Those are not the same, so this is false. Oh, I forgot to write true up here. So, again, the commutative and associative properties work for multiplication, but do not work for division. Okay, the next type of problem we have is that we're going to rewrite each expression using the property that it lists. So here we're using the commutative property. This is pretty easy. We just want to say, okay, it is 4 plus 5 right now, so let's write it the other way, because that's what the commutative property says to do. And that's it. That's our answer. So for B, we've got variables involved, but it's still that we just need to switch them around. This, by the way, this 7y, those have to stay together. And also when you're switching things around, whatever the sign in front of, whether it's positive or negative, has to do with what's right in front of what we have. So this is a positive 4 because there wasn't anything in front, so it defaults to positive. It's a positive 5 because it's a plus 5. Whereas here, same kind of thing. It's a positive 7y and a positive x. This is going to matter in a second, but right now we just had all positive, so it's like, well, of course they stay positive. If one of them was negative, the negative has to stay with whatever's right after the negative. That's how it works. So this was just switching it around. There's our answer. Let's use the associative property. So we've got 6 plus 11 plus 23. A different way of doing that would be to instead add the 11 and 23 together first. So we'd have 6 plus, and then we'd have 11 plus 23, like this. It's not asking us to actually work it out. It's just asking us to rewrite it with the associative property, right? On B, I'm using dots because I was also using x's and timeses all kind of look similar, so that's why there's dots here. So think of this 2z as being together as one thing. Right now, with the parentheses, it's saying, let's do y and 2z together first. Why don't we switch it so that instead we're doing x and y together first? So that'd be x dot y, and then we have a dot for 2z. That's what it's hoping for or looking for on problems like these. Now, let's use all the stuff and more to simplify by combining like terms here. When we're doing this, the properties that we have here are what help us be able to kind of rewrite this. If we have things that have a's, like we're saying this is 3a, by the way, that's a shortcut for writing a plus a plus a. That's what 3a means, okay? So we've got 3a and we've got 7a, then we've got some b's, then we've got a 10a. Well, those are all what we call like terms, so we can actually combine those. Anything that has an a here, we can put together, because here we've got 3 of them. Here we've got 7 of them. Here we've got 10 of them. So how many total A's do we have? So essentially we're choosing to do the A's first. That's like the associative property. And then we'll choose to do the B's second. Now this is why I was talking about negatives earlier. We want to pretend like this is negative 5b, even though it says 7a minus 5b. Essentially what we're doing is saying, let's turn this to plus and put a minus here, so that this is negative 5b. Okay. Then we've got positive 8b. But then we've got negative 12b. So again, let's think of this as plus a negative, if that helps. So we can do like this. So let's figure out how many A's there are and how many B's there are. 3a plus 7a plus 10a gives us 20a. Negative 5b plus 8b, and then minus 12b. This is another place where the associative property might help. It may be easier to do these two together first and then add 8b together, or it might not. But you can do it because we made it addition. That's what making this plus a negative helps with. We can do it in the order we want to do it. So I can do negative 5b plus 8b and get 3b, and then I can do 3b plus negative 12b, and that gives me negative 9b. So together I have 20a, and I could either write plus negative 9b, or I could write 20a minus 9b. This is like kind of tricky conceptually, this whole difference between subtracting and having a minus sign or having a negative. And it is something that will get easier as you just get used to using it more. I think typically people have kind of an aha moment of like, okay, I finally get it. I finally get how this works. But until then, you just got to keep trying, keep asking questions, keep checking your answers, keep trying to figure out, okay, why was this the answer when you don't get the answer right, and that will help. So let's look at B. We've got 2x. We've got numbers here that don't have an x, and these are capital X's, which I noticed our workbook, Math UC, using capital letters, which annoys me as an algebra teacher because I feel like we usually use lowercase letters, but it's fine. We're going to do 2x and then plus 15x, and then we've got minus 14x, so plus negative 14x. Combine those x's together. Let's see, this would be 17x, and you could either think of it as subtraction or plus a negative, because the difference between these, right, is 3x. That's how many x's we should have. How about you can mark these out then so that you know that you've already taken care of them. How about negative 8 plus 7 and minus 10? So negative 8 plus 7 plus negative 10. So that would be negative 8 plus 7 is negative 1. Negative 1 plus a negative 10 is negative 11. So this gives us 3x minus 11. And those are not like terms. We can't put together something that has an x with something that doesn't have an x. So keep that in mind as you're going along with this. Thanks so much for watching. If you enjoyed this, I hope you'll leave a like on the video. If you're not subscribed, then I hope you'll subscribe. Feel free to leave me a comment if you want to say hi or just whatever. And I'll see you in another video. Thanks. Bye.